Continuing education knows that at the end, students want to graduate, and we can help them do that because we take the time to really listen to their needs and we understand all the different options that are available across the campus for them.
We don't take a cookie cutter approach. We realize each student comes with their own story. So whether it's a part-time student looking to complete a degree program or someone just looking for online courses, we're there to connect them to the resources of the university.
All right, good morning, everyone. Today is Wednesday, April 9th, 2025. You're at the 9 a.m. panel, number 18131. The session is titled Beyond Earth, the Future of Humanity in Space. I'm pleased to moderate today's panel and spend the next hour or so with you learning from this diverse and fascinating set of speakers. My name is Chip Bollendonk. I'm a CU alum and an engineer at the Laboratory for Atmospheric and Space Physics here at CU. I design and build space instrumentation to conduct research about Earth, the Sun, and our planets and beyond, which is why I got signed up to moderate, and I will not be doing much talking and lots of listening. So we will start with a land acknowledgement. The University of Colorado Boulder, Colorado's flagship university, honors and recognizes the many contributions of indigenous peoples in our state. CU Boulder acknowledges that it is located on the traditional territories and ancestral homelands of the Cheyenne, Arapaho, Ute, and many other Native American nations. Their forced removal from these territories has caused devastating and lasting impacts. While the University of Colorado Boulder can never undo or rectify the devastation wrought on indigenous peoples, we commit to improving and enhancing engagement with indigenous peoples and issues locally and globally. We will do this by recognizing and amplifying the voices of indigenous CU Boulder students, staff, and faculty and their work, educating, conducting research, supporting student success, and integrating indigenous knowledge, consulting, engaging, and working collaboratively with tribal nations to enhance our ability to provide access and culturally sensitive support, and to recruit, retain, and graduate Native American students in a climate that is inclusive and respectful. All right, so I'll talk a little bit about question and answer protocol. So the CWA panel experience works best with a very engaged audience. That's you. And so I want to make sure that you all get a chance to ask your questions. So here's how we're going to handle Q&A. I will reserve time as we go to ask your questions and hopefully work them into the discussion. We'll be using a note card system. So at any time in the session, raise your hand, and one of our producers, maybe our producers can give a wave. Okay, so we've got 3 in the room, okay, 1 on each side. Just raise your hand, and they'll bring you a note card and a pen and pencil. Write your question on the card, and then you can raise your hand again, and they'll collect it and bring it to me. If you're a student, please note this on the card. And in order to accommodate the most participation, I urge everyone to keep your questions brief and to the point. And also very important is please make sure that I can read them. I'm not very good at reading cursive, so be very careful, because I would like to get to your questions. Okay, so at this point, I would like to introduce our panelists. We'll do a brief introduction. There's more information about each of these fascinating people online and in the bios that maybe you have in hand. I'll introduce everybody and then give them an opportunity for some opening statements, and then we'll get the discussion started. So we'll start here with David Brown. Is a freelance writer focusing on space exploration, climate change, and previously the secret inner workings of the government. A modern Renaissance man, David is a former U.S. Army paratrooper and Afghanistan veteran. He has degrees in creative writing and computer science and has joined 2 expeditions to Antarctica. Based in New Orleans, David's work frequently appears in The New Yorker, New York Times, and Scientific American, among others. His latest book, called The Mission, is relevant to today's topic as it explores the history of the recent NASA Europa Clipper mission to the moon of Jupiter. Welcome, David. Next up is Terry Chapin, who is an ecologist and leader of the Planetary Stewardship Initiative, whose goal is to reorient society towards a more sustainable relationship with the biosphere. Winner of the 2019 Volvo Environment Prize, Terry aims to promote stewardship with a general audience, and his work presents pragmatic approaches for all of us to shape a more sustainable future for both nature and society. Terry lives in Fairbanks, where he is a professor of ecology at the University of Alaska. Welcome, Terry. Next up, Shaniya Jarrett joins us from the University of Maryland, where she's pursuing a PhD in astronomy and astrophysics. Easy stuff. We're pleased to welcome her back to Boulder, where she completed her undergraduate studies in astrophysics. Welcome home. She's worked as a satellite test engineer and now studies binary black hole mergers, solar wind irregularities, and space instrumentation. Her accolades include an NSF Graduate Research Fellowship and Heising-Simons Foundation Women and Girls in Astronomy grant. Lucky for us, Shaniya is also interested in outreach and helping promote diversity and inclusivity in STEM. And finally, Ted Schmitt is the Senior Director for Conservation at the Allen Institute for Artificial Intelligence, or AI2, a research institute based in Seattle, founded by the late Paul Allen. Another world traveler on our panel, Ted has worked extensively in Africa with field organizations applying technology to secure and manage protected areas. He's previously worked for the U.S. National Academies of Science, several tech startups in Europe and in the U.S., and at IBM. In his current role, Ted leads AI2's Earth System program, which unifies weather and climate forecasts, satellite imagery, radar and GPS data into a single integrated platform to support users tackling diverse environmental and planetary challenges. And we're going to learn everything that they have to share with us. So we'll kick it off. Maybe, David, you can get us started. Thank you.
Thank you very much. Good morning. Can everybody hear me okay? Great. Okay. So, I mean, this is a pretty broad topic, so I'll try to set some constraints on it, or at least give some perspective on things. When we think about space exploration generally, let's just talk about the entire American space program. It's responsible for some of the most extraordinary, in fact, the most extraordinary human achievement is probably putting a man on the moon. But in our everyday lives, we feel the effects of NASA profoundly and constantly. And it also has these sensational landings of Mars rovers using sky cranes, and we recently launched Europa Clipper, which is the largest spacecraft ever flown by NASA. It's about the size of an NBA basketball court, and it's going to study the habitability of Europa, which is the ocean moon of Jupiter. For all of these extraordinary achievements, and for this constant round-the-clock positive influence on our lives, and there's some negatives, but overall I would say I like having GPS in my car. We spend about 0.5% of the federal budget on this. When we talk about human space flight, putting people in the International Space Station, landing people on the moon, that's about 1/3 of that. So 1/3 of 0.5% of the federal budget. This is not a lot of money. We could eliminate NASA tomorrow. We could stop spending every dime of taxpayer money on space exploration, and we would never notice it in our tax returns every year. So it's probably useful to keep in mind that despite the enormity of the things that we wish to do in space and the enormity of the things that we have and will continue to do, it's really not that expensive. It's probably the best bang for your buck you're getting in the federal government today. What else do we get? So it's very easy to say, why are we studying Venus? Who cares? And that's a fair question to ask. Why are we studying Mars? Why are we studying Europa? Well, we studied Venus in the early 1960s all the way through present day, and we learned about something called the greenhouse effect. Probably pretty important. Venus is basically Earth, just if you're unfamiliar with it. It's about the same size, made of the same stuff. It has vaguely the same orbit, but for some reason its surface is 900 degrees. This is a direction that we do not want the Earth to go, although we're doing our best to make it happen. We talk about colonizing Mars. Well, I mean, there are some good questions asked about why we would do such a thing, but keep in mind, the important part about colonizing something like Mars would be growing food there. If you can grow food on Mars, you can grow food anywhere on planet Earth. So we've got to solve those problems here so that we can solve those problems there. Europa, I mean, that's getting down to the most fundamental questions of human existence, right? Where do we come from? Where did life begin? There would have been a second Garden of Eden at the bottom of Europa's oceans if indeed life has, if indeed there was a genesis there. And by studying how that might be, we had to study places like in Antarctica because that's the only analog on Earth. Why does that matter? Well, in preparing for the Europa Clipper mission, we flew a radar we built a specially constructed radar, flew it in Antarctica at Thwaites Glacier, and what did we find? The Doomsday Glacier. We actually found probably the single greatest point of instability in Antarctica, and a place that we definitely need to keep our eyes on going forward. But we only did that. We only had that radar because we said, you know, in 30 years we want to go to Europa. So these are things to keep in mind. None of this exists in a vacuum, no pun intended. But it is something.
Some of it doesn't exist in a vacuum.
That's true. That's true. So it's never about space. I think it's always about Earth ultimately. So that went on quite long there. But thank you very much for being here this morning and for being such a kind audience.
That's a wonderful introduction, David. I was thinking along the same lines. Why do we want to? Why might we want? Thank you. Why might we want to extend our exploration of outer space? And I can see a variety of different reasons. As a terrestrial ecologist, I come here mainly as a learner rather than somebody who's in a position to provide insight. But gaining new knowledge, such as David described, is really an important opportunity in outer space. And I'm sure there's lots of people who've put lots of thought into how this can be done most effectively. Another reason might be to extract resources to enrich life on Earth. But then, as David was saying, there's lots of ways in which we can improve the things that really matter to people by doing things on Earth. And so we might want to think carefully about the value of bringing resources back to Earth from other places. Finally, or next, maybe expanding places for people to live, new habitats for people. But it's hard enough to create long-term sustainable habitats on Earth. So to what extent would this be desirable in other places? And finally, I think some of the reasons for the history of space exploration have to do with human hubris and competitive issues on Earth. I think it seemed to me that the race to the moon was largely a response to human hubris. We can do it, therefore we should do it. Is that sufficient motivation? But then there's other motivations for near Earth space activities that have to do with economic and military advantage. And those are certainly issues that involve societal issues. There's certainly topics that involve societal issues on Earth. Thank you.
Hi, thanks for having me here today. So when I think about humanity as becoming this interplanetary species, the first thing I think about is, well, why do we even want to go to space? And so I kind of have three main ideas on that. And the first is that I see humans as these visionary creatures. I think there's this emotional response that we have that drives us to keep doing things that seem impossible to us. And I think humans love being told we can't do something, and then we do it anyways. That's just how we are in nature. But space is this constant thing that's being dangled in front of our face, and it's there to challenge us. And so if our imaginations are constantly trying to reflect what's out there, then what is unknown will always be exciting and interesting to us. And I think by going to space, then we are moving closer to figuring out maybe where we came from, where we're going, and what's next. And then there's the evolutionary angle where humans, we constantly want to expand. We want to learn how to survive and thrive in environments that maybe are not made for us. And that is not exclusive to humans. Animals migrate, plants spread their seeds, bacteria learn how to thrive in harsh environments. And so it's not unique to us, but it's something that is innate to us, and it's what drives us. And then I also think, Mars might be next. But in the far future, maybe terraforming Mars will be our dry run for moving to further planets. And if you're worried about the time frame, the good news is that at most we have 5 billion years to figure this out, as long as we don't make any mistakes along the way. And then the last one is that political aspect of if you have this unclaimed territory and it seems like there are unlimited resources, this is a country's wildest dream to get there first. And it's also probably a bit of a threat to have somebody have this advantage of being able to take over this planet, being on Mars, and that'll really change the power dynamics we have here on Earth. So I think if we want to think about how are we going to pull this off, how will we get there, and what kind of future do we want to build for ourselves later, the first question that you ask is why do we want to do it in the first place?
Wonderful, thank you. Wow, great thoughts from all the panelists. I will maybe bring this back to Earth, and I'm sure many or most of you have heard the concept of spaceship Earth. We kind of are on a spaceship, and our little marble floating out in the universe. I think it's a pretty special place. I think we human species are causing a lot of damage on this very special place. And what's interesting is the things we put in space, so I'll try and bring it really practical, some of the things we're doing on a daily basis with satellite data. We've written AI models to understand movement patterns of fishing vessels at sea and determine whether they're fishing illegally or not, and then giving that information to countries to be able to enforce their own laws against that. It's needle in a haystack stuff that's really only possible with a combination of satellite data and AI. An analyst, a fisheries analyst, could look at the satellite data, but it doesn't scale, and so you have this massive amount of data. I forget how many petabytes of satellite data come to us from space every day, and actually the combination of that data, which is only increasing, in combination with AI, which can process it and embody the knowledge of experts, is enabling us to monitor our planet in ways we'd never imagined. We took the same models, and this is where I find some of the stuff really powerful. We took the core of the same models and retuned the models so that we could detect when animals were moving in a way that the elephant scientists could tell us they were staging to go crop raiding into a village. And then giving that information to the local community to be able to keep the elephants, keep themselves safe, keep the elephants safe. And those were based on the same models with the same sort of GPS data. In an example of putting satellites in space and not being sure exactly what to do with them beyond a few things, but then doing amazing things. The European Space Agency has two satellite constellations up, Sentinel-1, which is a synthetic aperture radar, and Sentinel-2, which is electro-optical, so the imagery, the photographs that we all see in Google Earth and so on. And we're applying, and when I say we, I don't mean just AI2, although we're certainly active there, but many people are applying models, computer vision models, to that data to do all sorts of things, just to understand the extent of different types of ecosystems, and scientists have classified ecosystems. We don't even have right now, this is sort of amazing, our little planet, we don't have a stock of the different, we haven't classified the ecosystem. So if we haven't done that, how do we know what we have? And if we don't know what we have, how can we save it and protect it and manage it appropriately? And so what we're putting in space is actually enabling us to potentially, again, with the political will and the social values and ethical values, it's giving us the data to be able to do a lot better job of managing the planet than we currently do. And so that's what I get excited about space. And I think David said it well, the benefits are everywhere around us, and we sort of don't even notice them. And I think it's a great example of doing science for science sake and then letting people figure out all the ways to do it. I am quite certain that no one ever imagined that you'd be able to give local communities in Africa data so that they could keep elephants out of their cornfields when they were launching satellites. So I think that's just a nice example. So I'll stop there.
Excellent. We'll address a couple of these comments that have come up, and a reminder that if you folks in the audience have questions that you'd like to ask, just raise your hand, and our producers will bring you a note card, and you can write it down, and they'll bring it up to me. So I like David's point that Ted just reiterated about the benefits that all of us eventually feel from NASA and space investments, and certainly the village in Africa probably doesn't have the funding to develop a space program to monitor the elephants, right? So that's a ride-along benefit, perhaps. At what point do you think that those investments stop, to use a controversial term, trickling down to the rest of us? At what point do we go so far out that, day to day, we won't see any benefits anymore? This is for whoever would like to respond.
Sorry, you said the benefits trickling down, and at what point?
So, the ballpoint pen was invented to write in space, right?
Indeed.
At what point do you think we've innovated so much that us here have gained maximum benefit, and beyond that, it's getting simply for hubris' sake, as Terry mentioned, or
It's something we as a panel were talking about before we started was, why? What's the? And Shaniya said it very well. We have a hunger. I think that's a special thing about Homo sapiens is we have this hunger to grow our knowledge and to understand and explore and to seek knowledge for knowledge's sake, not knowing necessarily where that's going to go. So I don't know that we'll exhaust it. I think there are so many mysteries, both here on Earth and in space, to explore, and we don't know where those would go. It's what we do with that I think is with that knowledge that's so important. And I always say that about technology. People will say technology will fix this or that. Well, technology won't fix anything, and science and understanding knowledge won't fix anything, because you can use those things to do good things or bad things. It's a decision that we humans have to make. So I don't know that we would ever exhaust. As long as we're gaining knowledge, there's always potential to do new and interesting things like create ballpoint pens or protect villagers and elephants in Africa. And I think we can't guess where that's going. That's sort of a fundamental thing about knowledge creation. We don't know quite where it's going. So I don't know if anybody else has something to add.
I would add one thing to that. I think that was very eloquently stated. One thing I would start with is that we haven't finished innovating the ballpoint pen. We keep finding new ways of doing it. So we could probably extend this indefinitely. But there's something to be said for, I think one reason why, when we talk about space exploration, we went to the moon, we're going to Europa. We always use the word we. Have any of you here been on the moon or put people on the moon? Probably not. You have. But overall, I would say space and war are probably the only two human endeavors that I can think of where whenever we talk about it, we use the word we. One is an inherently violent and destructive act, obviously war. Space, though obviously it does have military applications. Overall, and I think a great deal of credit goes to NASA for its stewardship of the American space program. Though the S in NASA does not stand for science, that really has been the organizing force behind it. Think about the engineering that went into the James Webb Space Telescope, and there's no strategic advantage to being able to see 13 billion years into the past and into the deepest recesses of space. We do it because it's the right thing to do, because fundamental science is important. It's important not only because we're going to achieve some material benefit. It's important because as the human race, this sort of research is what we owe the future, and it's a debt that we're repaying to the past. And I would like to think, although the last couple of months have given me great pause, I'd like to think that we will continue doing those sorts of endeavors. Again, not for some immediate material or monetary benefit, but because we need to know. Why do we need to know? Because we're human beings, like you were saying. This is what we do.
Those are really good points. And it seems to me that on in our everyday decisions, we're often trying to weigh immediate benefits and costs with long-term benefits and costs. And it does seem like space exploration gives us a much longer time horizon to consider.
Right.
And that's something that we desperately need here on Earth, is just to think about the importance of the time horizons and how much we owe to the future, and what our actions here today will do to that. So I agree with what you're saying.
I have a related question that's coming from the audience. We can maybe adapt the question to kind of lead off of exactly what Terry was just saying. Can you discuss future business opportunities in space and on what time frame they might be realized? And the important clarification is sooner than 5 billion years and further than tomorrow.
I guess I would first answer kind of the second part of your question and the time frame of when we expect to make these achievements. And so I think to put it into context, when we say we're going to explore space, well, where exactly do we mean and when? And so our nearest exoplanet is called Proxima Centauri b, and it's about 4 light years away. This is very far. And it's around a star called Proxima Centauri. It's a very young star. This planet is getting blasted with radiation all the time. And so the fastest spacecraft that we have moving away from the sun right now is Voyager 1. And so it's moving at about 60,000 kilometers per hour, which is, I think, 40,000 miles per hour for reference. And so even if you have this spacecraft that is the size of a car traveling that fast, it would still take us 70,000 years to get to our closest exoplanet. So I don't think, it's within the next few hundreds of years, it's not feasible to expect that we would end up anywhere outside of our solar system, but I do expect that that's a long enough time frame to explore what's in our solar system. And so until we make some incredible propulsion advancements, then we're kind of staying in this area. And then what did you ask about business?
Oh, I think the question is, what's on the horizon? What are the big opportunities?
Exploring more of our solar system is definitely, it's feasible. Going to Mars is going to happen in our lifetime, but I wouldn't expect anything outside of our solar system while we're still around. So that's just to give you some context.
All right. So a couple of similar questions here. I like how this one is written. Does the idea we might colonize other planets and moons create a disincentive to take care of Earth? And then maybe we'll start there. Yeah.
Anyone who would be so short-sighted as to say, I want to colonize Mars because the hell with Earth, I think that would be a nice, expensive way to commit suicide. You have to keep in mind that Mars colonization, for example, we'll just use that because that seems to be the destination du jour. Actually, it's been the destination du jour since 1971. Like, there's a saying, we've always been 20 years away from colonizing Mars. It is so far beyond the least hospitable compared to anywhere on Earth, even the worst places on Earth. If we go to Thwaites Glacier, as I have, and it's horrible, that would be a paradise living there would be a paradise compared to spending one day on Mars, if only because you can breathe at Thwaites Glacier, if only because you won't die of immediate, you won't contract cancer in the next 5 years because of cosmic rays at Thwaites Glacier. If only because if you do need to get food from somewhere, it's only a couple of days away, where Mars would be several months away. I don't believe that it creates a disincentive to take care of Earth. As I mentioned in my opening statement, the technologies that have to go into cultivating Mars, literally every one of them applies to Earth. For example, the big problem with growing one of many big problems with growing crops on Mars are the perchlorates in the soil, right? We plant things there. The plants draw up these very unpleasant, if not lethal, chemicals, and you eat the plants and then you die. But perchlorates are a problem on Earth too, and they tend to be the Superfund sites, right? The places that were Superfund, F-U-N-D, not Superfund. The toxic waste dumps, right? That's where we see perchlorates as a pretty big problem. But we're doing, there's that word we again. I'm not doing any of this research, but we are doing this research to solve that problem. Like, what microbial life can we introduce to these toxic waste sites that will rehabilitate the soil, so that again we can go to these areas safely, and one day we can actually make the soil arable, if not one day healthy. These are problems that have to be solved here in order to solve them there, and we're making great strides in doing that. The timeline for a self-sustaining Mars is so far off, where we would have to make a decision like, do we worry about the new planet or do we take care of the old place? That's so far beyond our lifetimes that we may as well be talking about our Proxima Centauri vacation.
I would not recommend going to Proxima Centauri.
I would love to hear a response, if I may solicit one, from Terry. Terry, professor of ecology. Do you see a conflict, between investment in space research and exploration and your own ecological work here on Earth?
No, I don't see any conflict at all. And I think David said it very nicely. It's a really small, the space budget is a really small proportion of the resources that we spend learning new things, doing things for the benefit of ourselves today and for the future. So I see it as a wonderful opportunity to gain new knowledge. And for me, one of the questions about extending into outer space is how much of it can be done from the Earth or from near-Earth satellites, and how much of it requires visitation to these planets. And I think Shaniya and Ted probably have more to say about that than I do. But I see there's, like David said, there's so many problems that we can resolve here at home. And these are such solvable problems that I think if we make a firm commitment to solving problems at home without worrying about whether this is competing with resources dedicated to outer space, that would seem a reasonable approach.
I guess I think David and Terry have really, the perspective here, Shaniya also, like, new knowledge is good, but the time frame for us, and I have read stuff about, we could just colonize Mars if we mess up the Earth, right? I mean, people have said such silliness. Some supposedly very smart people have said such silliness.
We're only 20 years away.
I won't name names, but it is silliness. Does that make exploring space and exploring going to other places not make sense? No, that knowledge creation is wonderful. But the reality is, it is way beyond any of our lifetimes, decades, centuries, before we could practically do that. And why should we do that? We have a perfectly wonderful planet here. It's still wonderful, despite all of the Superfund sites we've created and everything else. And what I see, knowledge creation and going to these places is wonderful, and right, the cost is not that much for the knowledge we're gaining. But the most interesting thing to me, and the thing that I deal with every day, is that the data we're getting from space, from near space, to help us do a better job of managing this spaceship we're on right now, is truly invaluable. And in fact, given the rate at which we humans are impacting the planet, and doing it in ways that aren't considering the long-term impacts, and to use the ecologist term, ecosystem services that nature provides us, we're not factoring. That's not factored into our economic system. And yet, right now, because we've got things in space, we have the data to actually understand much better what we're doing and to do a much better job of managing it. So while I'm totally for doing that deep space exploration and sending, spaceships to Europa and Mars and creating that knowledge, the most immediate investment, certainly in any of our lifetimes or probably our great-grandchildren's lifetimes, will come from being able to do a better job of managing the spaceship we're already on.
Hear, hear.
Do you think that the public, they clarified us, US and Europe, but maybe broadly worldwide, is more interested in space now than in the past, perhaps the 1960s?
I guess I would say, we all have, I bet every person in here has a cell phone in their pocket, right? That cell phone is attached to space right now. It lets us go out the door and put in the name of a restaurant we want to go to and walk or drive there. And it lets us, I could go on and on and on, right? All of that is enabled by what's up in space right now. So I don't know that we're more or less interested. I think we just take it for granted, so much of it. And so I think that's more like, we have to really think about, we're going to go to Europa to really make space interesting, right? Because we take all of the boring stuff for granted now, even though if it disappeared tomorrow, and we had a little discussion about how that could happen, right, that we would be like, oh my gosh, how do I find my way around? I'd have to, my mother still uses paper maps. She just doesn't, she's 90 and she doesn't deal with pushing buttons on the phone. So she could help us navigate still, so.
One of the interesting things that we all have this like happy, warm vision of the past. So 1969, Neil Armstrong and Buzz Aldrin walk on the moon. And we just assumed that everybody was like pretty excited about that. How thrilling, right? The next day in the New York Times, I think there was a poll that came out of something like support for the moon. This is after we've landed people on the moon. The support for the space program was something like 30%. And the big question was, why are we doing this? Now I think that we sort of, again, we take it for granted. Like, yeah, of course that was an extraordinary thing. It's like, this is Boulder, Colorado. Why do you climb mountains? You do it because it's there. I think the same thing is true to a great extent. We kind of see the value in retrospect. Is there more interest now? I don't know. I think that there are more opportunities now. There is a non-zero chance that 5% of the people in this room will go to space in their lifetimes. Like as the cost of access to space goes down, I know a lot of, look, it pains me to say any kind things about Elon Musk right now, and I won't. But there's a contingent of people who feel like every time these millionaires go to space, it gets kind of annoying. For me, I wish they would all go to space. Some of them I wish they would stay there. But the sooner we get these people into space, the more people we get into space, the lower the cost of access to space is going to be, and that means I get to go there at some point, and I think that would be pretty cool. So I do think the interest is there, but I do think I do agree with you that so it is so deeply intertwined into our lives that it is almost boring, which is how incredible.
It is.
I bet people have always fantasized about space, wondering what it was, what was there, and what it would be like. What would it be like to me if I were there? And so people have fantasized about that, and these fantasies are sources of imagination. And one of the biggest challenges in any sort of issue, and especially some of the serious challenges we're facing on Earth, is having more imaginative approaches to doing things that we've sort of locked ourselves into a pathway. And so in that sense, I think having fantasies has always been a wonderful thing, has opened up opportunities for innovation. And in that sense, I can see having fantasies about space today and then pursuing those with the benefit of knowledge is a pretty exciting pathway forward.
Okay, I'm going to shift gears a little bit. You're all doing a great job with questions, so please keep it up. I'm building card houses up here to keep them all organized. So there's a lot of similar themes. So I won't read every question, but know if there's something similar, I'm grouping them sort of intentionally. There's several questions here that relate to dealing with life that we may find that we don't yet know of, out there. Everything from, a reference to H.G. Wells and War of the Worlds, and differences between, how Martians respond to, microbes here on Earth versus Earth population, and restrictions there. Let's see, I'm going to resort that one. Questions about if we go to Europa in hopes of discovering life, which, if you're not familiar with the Europa mission, is one of the maybe not explicitly stated, but certainly hoped for goals. Are there ways to ensure that we don't seed Europa with our own microbes? How will we know that we found life beyond our planet there? And then maybe similarly, how close are we to discovering extraterrestrial life, whether intelligent or microbial? There's a whole lot there, but hopefully you can comment on that.
So I have to mention, so I worked for Paul Allen and now his family for 17 years. And when I first started working for Paul, he was very interested. He's very interested in wildlife conservation, which is what I focused on for the last 10, 12 years, but very interested in space exploration and very interested in extraterrestrial life and what it would mean for us to even find out that there was definitively extraterrestrial. Like, what would we think of our place in the universe? Like, how profoundly would that change it? And in fact, one of the things that I got tasked to do early on, even though I know nothing about astronomy, was to go and try and identify radio. He was very interested in radio astronomy because that's how we look for, and you've probably heard of the SETI Institute, and looking for radio signals that have to be sort of, that would indicate it's some conscious intelligence that is transmitting the signals. So it is the ultimate needle in a haystack. In fact, it's a needle in a billion haystacks chance. And even just if we can show that there are microbes on other planets, that's already or I think Europa is where we're looking for that. I mean, even if that can be confirmed, that will be very interesting because it will probably say, I think somewhere in this vast universe there's got to be other life forms, right? And then I go as a conservationist to thinking about the relationship we have with other species on our planet. What relationship would we as humans have to other species in the universe? And would we yeah, anyway, I'll stop there because I could go on and on. But those are the kinds of questions that start popping up for me.
Yeah, this is always a fun question. I think it's probably the biggest one that anybody in astronomy or astrophysics would want to know. Are we alone out there? And so I think statistically the numbers are too high, and I say that because just in our solar system alone, we're hopeful that maybe there was water on Mars, maybe there are microbes in Europa. But when we start to look outside of our solar system and look at how many stars are there in our galaxy, well, there are a vast number of stars. And if we assume that each of these stars has at least one planet, and if we know that there are hundreds of billions of other galaxies out there, when you do the numbers, we estimate that there are 10 to the 24 exoplanets out there. That's a septillion. The number is septillion. You don't ever hear about that. And it's very hard to comprehend such a large number. And so we would hope that at least on one of those planets, there is some other form of life out there. And so you're sitting in this position and you're frustrated saying, well, where are you? And it's called the Fermi paradox. If we have all of these planets, but we can't find any life, there's kind of a mismatch there. And so I think there's a lot of different theories as to where we think it could be. Maybe the biggest one is that they're too far away, that they exist out there, but by the time any signal would reach us or we reach out to them, maybe the civilization has already started and passed. It could potentially be life forms that we don't even understand what they look like. It's natural to assume that they might be carbon-based like us because that's what we have as a point of reference, but it could be something completely unrecognizable. Maybe Earth is just a TV show and they don't want to interact with us for whatever reason. There's a lot of unique theories, and I think it would be extremely exciting and encouraging if we did find anything in our own solar system, because that would give us an idea of what other forms of life could look like. And if we can find that here, then maybe we could find that in the next star system. So I really hope that we find something before my time passes. But, if you've ever seen the example of how long civilization has existed on a calendar of the universe, I think we fill the very last second and the last day in December. So we're really just a blink. Our whole existence is just a blink of an eye. And so maybe we haven't had enough time yet to meet something else, and it hasn't come to us yet either. So that's what I think about that.
I would add to that, actually, to what both of you said. I remember when I was young, the Mars exploration strategy was driven by the concept of follow the water, right? If we could find evidence of flowing water on Mars, that would probably mean, where there's water, there's probably life, and so that's where we need to look. But for most of my youth, if I'm remembering it correctly, finding that water was nearly impossible. It just was so rare, and that's what made Earth special. Like, water just didn't flow in other places, and maybe the strategy on Mars was kind of foolish. But today, it's hard to find a celestial object where water didn't flow. And I have a feeling that though the search for life has thus far come up empty, I think that once we find life somewhere, I think we're going to find it everywhere. I think it's going to be an almost instantaneous and overnight event. We'll find it on Mars. We'll find some ancient extinct microbe from 3 billion years ago. We'll find it on Europa, maybe fish swimming around in the sea, although that's decades away. And at that point, we're going to start, we've already found at least evidence that there are habitability zones on Mercury. I mean, if you can have life on Mercury, you can have it darn near anywhere. The clouds of Venus, like, we're getting more inventive as we have more and more data. One of the problems is there's no such thing as a life detector. It's not Star Trek. Like, we can't just scan for life. That does not exist. And so that's one of the problems. One of the other problems is, well, what would life look like there, right? We assume that it would be carbon-based, but it could be based on methane. What does methane life look like? Touching on what somebody else, one of the other questions that was posed, how, and I think Ted touched on this, how do we interact with this, whatever this life might be, right? So when we look at life on Earth, every single thing, every blade of grass, every Christmas tree, every ocelot or koala bear or giraffe or kangaroo, I don't know why I'm getting hung up on Australia there, but everywhere that there's life, every human being, we all come from a common ancestor, some hundreds of millions, if not billions of years ago. And if to the extent that there is any moral justification for, say, eating meat, that moral justification is, well, you know what, our ancestors went ahead and solved that problem of who was higher on the food chain. So morally, that's my high ground, right? We fought that war and we won. But what if we encountered life that is not part of our common ancestor, our heritage, so to speak, as a living creature? Is that even an animal if we find a fish on Europa? Is that its highest life form? How do we interact with that? And these are questions we don't have answers to. I certainly don't. Could you eat a fish on Europa? Would that be some unpardonable sin? I don't think that that's going to be, again, that's not an issue we're going to deal with in our lifetime, but it's a question that philosophy should probably set about taking a hard look at. And the discovery of life, indeed, would transform philosophy. It would transform science. Certainly, it would be the most important scientific discovery in human history. It would transform religion. 2 Gardens of Eden, I don't recall reading about that in chapter 1. So yeah, these are exciting times in that regard. I really do hope we find life. No expectations, no disappointments. If it happens, it's great. If not, that's okay too. But deep down, I want to see it.
Okay, so I want to bring in our ecologist now, who studies life that we know about. Terry, are you and your team waiting with bated breath for, Shaniya and her team to say, "Look, we found something. Your turn."
Well, I think we have enough issues to deal with already here on Earth. So I'm not holding my breath, especially if we're talking about millions of years. So I think there's wonderful opportunities here on Earth to shape a future in which both nature and people can thrive, and I think there's solutions to most of the near-term problems, and so that's where I think I would like to continue to focus.
A couple questions have come in related to the comment that David just made about, finding life and using the life detector. That's what we do at my job, is we design life detectors, but they're not called that. They look at one particular thing. I'm wondering if, a couple of our panelists could talk about what does science instrumentation look like? And one of the questions said, are there plans to put new technologies, instruments on new satellites, and what new information will they provide? The answer is certainly, as long as I have a job, yes. But I'm hoping you can comment on that.
Yeah, I can kind of talk on this. So earlier, David mentioned, we don't have the life scan that you see in Star Trek, but I think the closest thing that we do have is just using spectroscopy. And so we like to analyze the atmospheres of other exoplanets. And so spectroscopy, if you can think of every chemical element having its own fingerprint, and it's unique. And so if you look at the atmosphere of an exoplanet, you can tell that it is hydrogen from very far away because there are very specific absorption and emission lines in that spectra. And so if we are looking for something like carbon or oxygen, we can see that, and then that can kind of lead us into, there's potential on this exoplanet for life, but there's still so many other characteristics that this planet would have to have. It would have to be in the habitable zone, where it's like the Goldilocks region. It's not too close to the star, it's not too far away. It has to have the right atmosphere, and things like that. So that's just what I thought of when David mentioned that. And so there are a lot of different instruments that are able to look at this. Even James Webb is being used to look at exoplanet atmospheres as well, even though it's also looking at galaxies and stars and other things. So I think we have the tools to do it, even if it's not, a full scan of there's life on this planet.
There was I believe it was in the 1990s, NASA, or maybe it was the National Academies, commissioned a study. I think one of the head of the Salk Institute was part of it, and NASA said, we want to find life. Like, we want to be able to just flip the switch and say, okay, it's right there. And so the scientists went about solving this problem. Like, how do we do this? And the first problem they encountered, and I don't think it's a problem that they ever fully got through, was, all right, guys, let's do it. So how do you define life? And that's a question that to this day there's still bitter debate over what is alive, right? Is a virus alive? By some definitions, no. By some definitions, yes. And that has become sort of an ongoing discussion. A couple of years ago, NASA, or scientists at NASA's Jet Propulsion Laboratory, very much wanted to develop a lander for Europa. So Europa Clipper, the spacecraft that launched in October, is a multiple flyby mission. It orbits Jupiter, and it encounters Europa at different angles and sort of collects strips of data at a time, sort of like peeling an orange almost. In reverse, I guess, because we're actually filling it in. But they wanted to build a lander too. Like, they had the congressional support, and they said, okay, we're going to put something on the surface of Europa. We're going to dig 10 centimeters into the ice because you got to get below the irradiated surface, and then we're going to go ahead and find life. That's what we're going to do. This is a life detection mission. And because the instrument didn't exist to just scan it and find it, they essentially created a matrix, or like a very large bingo card, where across multiple domains and dimensions, using various instrumentation, they would say, okay, this box is checked, this box is checked, this box is checked, so that's 3 out of 7, so that doesn't meet the categorization. But we got 3 out of 7 on this one, we've got 6 out of 7 on this one, so we put those together. So anyway, The idea was checking enough boxes, eventually you could say with relative certainty, there's something alive here. Obviously, that mission never flew, but I always found that very moving. Ultimately, the practical result of that was going to be, if indeed they did find life, it would the greatest result that would come out of that would be maybe, which we already know that answer. So it is a problem that is seeing ongoing discussion. But again, it goes back to what we were talking about earlier. How do you define life? I think Shaniya said that very well. Like, what does non-carbon-based life look like? I don't know. Like I said, we can't even define this life. So it gets very quickly into the realm of science fiction, but it's fun to think about, I guess.
Great transition. Maybe my favorite question so far. What, if any, science fiction media has inspired you? I think that's appropriate, right? Yeah.
I mean, the science fiction I find most fascinating is when humans are traveling with other. I'm trying to remember, it was years ago, I read a science fiction novel where dolphins, which are very intelligent, were traveling with humans as equals in outer space and exploring outer space. I can't remember the author, but I found that maybe the most fascinating thing I read, because it was that other species on Earth had evolved to a point where they were creating knowledge as well, and they were being treated as equal species on Earth, and they were exploring outer space together with Homo sapiens. So I find that really fascinating, because that's something we barely think of. And it goes back also to, what if we did definitively find other creatures in space? How would we treat them? I mean, philosophical, ethical questions. If you see an ant on the floor, you might crush it because, I don't want ants here, right? But that's a living being thing that's highly evolved, and we just crush it under our fingers. Would we do the same thing with other species? Or would we travel in space with other species because they've reached some level of intelligence that is sufficiently interesting to us humans that we want to engage them as co-equals? I think that's super fascinating. Okay.
On the topic of bugs, I'll share my favorite sci-fi, but maybe it's not the most inspiring. So I've really enjoyed the three-body problem. I don't know if anybody's, there's books and there is a series on Netflix, and I thought it was just fantastic. However, the scenario is that we've contacted this species, and it's exciting as humans, we found something, and then somebody sends a message back saying, don't reach out to us again, we're hostile. And so the rest of the series is based on what's called the dark forest theory, where other civilizations stay quiet because they don't want to be found by more hostile life, which I certainly hope isn't the case. And then there's a saying that, they call us bugs. And so you're mentioning, would you just squish a bug? How much would you care about that life? I think it's very well done, and it's fascinating on its own. But in terms of other sci-fi that's maybe more inspiring, I really enjoyed, it's called The Expanse. And the reason for that is because I feel like it's a somewhat realistic depiction of where we could find ourselves in the future. And so you have a colony on Mars, you have people in the belt that they call belters, you have all these space stations, and there's a lot of political turmoil between people at the in-between, people on Earth and people in Mars. So it's always exciting to see how people envision things panning out for us. I think there's a few episodes where there is kind of a bioweapon, which is something to consider too. But I've always been a huge sci-fi fan, and so it's really exciting for me to get to do this kind of work. I just think it's great. Yeah.
Star Trek.
Terry, any sci-fi for you?
No, I've never read any.
Any science? Not non-fi? Non-fiction?
Well, we've been talking about that most of the morning, so I'm not sure I have anything to add.
Okay. So there's been some talk about ecosystems, and so I'd like to move a little bit to humanity in space. There's been some great questions about what ecosystem do we bring with us. Do we bring a pet as an emotional part of our ecosystem, or do we need to bring an actual food chain kind of ecosystem and all that comes with it?
Well, I'll mention as with the panel was chatting beforehand. A couple of us were on a panel yesterday, and some statistics were shared that I think it's something like 64% of all biomass are the animals that we eat, that are livestock, and 30, if I'm doing math, 4% basically, and then whatever the math is there, 30-something% are we humans, and 4% are all other animals alive. Imagine taking that percentage into space. Like, would we bring cows into space so we could consume them? Probably not, right? It doesn't seem very practical. So what does that look like, and what would we take into space, and why would we take other species into space? It's a fascinating question. So, I don't know.
There's a TV show. I don't get a chance to watch TV very often, but it was called Fallout. I don't know if any of you have seen it. And the sort of the premise of the show is based on a video game, but the premise of the show is this company builds these nuclear vaults, and then nuclear war happens, and people have gone into these vaults, and they're emerging for the first time. There's a scene that takes place in pre-war times, before the people go into the vaults, where the main character, he's very unsettled because the company that built the vaults doesn't allow dogs, because they would be just consuming resources. And he finds this very unsettling because it's kind of like an assault on freedom in a sense. Like, the company's point is, look, we built them, we get to make the rules. And his point is, yeah, but shouldn't we at least have a discussion about this? Why should they get to make all the rules? I think that applies perfectly to this topic when we start thinking about, say, SpaceX setting up bases on Mars and eventually colonies on Mars. This company is spending their money, and we would be paying them to go to the bases that they've built. And I don't know, but I suspect that dogs won't be allowed. Why does that matter? I mean, on a small level it doesn't, but on a much broader level, the companies that are establishing, or let's say will establish these outposts, because I don't think it's going to be a NASA-led endeavor. I do think it's going to be a commercial-led endeavor. They're going to make the rules about how we live. And I don't know about you, but I'm not 100% sold on Elon Musk making the rules about how I live. We're seeing how he does it on this Earth, and it's not great. I don't know that I want to be completely dependent on him on Mars. Just something, again, this is just something to think about.
Maybe I'll just add something, as you specifically asked, what ecosystems would we take? What I find fascinating is I mentioned that we're using data from space to characterize ecosystems. What's fascinating is the most, and David alluded to this earlier, some of the most hostile ecosystems on the planet, some of the driest deserts, have some of the most fascinating biodiversity in them. It's sparse, but it is amazing because these creatures have evolved to live in these incredibly difficult spaces. I got to go to the Atacama Desert last fall, an amazing landscape. One of the driest places on the planet. There are places that hasn't rained in 50 years, and yet it gets a few drops of rain, and suddenly some plants that have been basically hibernating for decades pop up, procreate and disappear again, and that's amazing. So how would we decide what ecosystems to take with us? I mean, who are we to judge what makes sense, right? So anyway.
Y'all are going to have to solve this. Maybe we could solve it right here.
Yeah, our next session here is going to be a slideshow from Ted's trip to the desert. Yeah. Okay. So we've discussed that a lot of this is far away, right? We're 20 years out from colonizing Mars. Okay. But there's still a lot of development to be done. Should space ethics be proactively established now, or can they evolve reactively as we go?
I wonder if it has to be both. You start where we are and then think about how circumstances, what are possible pathways that might emerge as we explore space, and then think about what would be the ethical issues associated with choosing among pathways where there's opportunities to choose, and then pursuing those beyond that.
Yeah, I agree. I think we need to start thinking about these things. There are so many ethical and philosophical questions. If and when we do find life, other life outside of Earth, that does, as David already said, raise enormous questions across every range of human thinking there is, and even how we go into space, it raises so many questions. So I would hope that philosophers are already thinking about this, and then it will have to evolve as we learn.
I would also add that if we are to find success as we venture out from Earth, it's going to require a significant amount of collaboration from as many countries as possible. I think this is a human issue that we are looking into, so everybody deserves a seat at the table. And then you have to decide, well, who actually gets to sit at that table if you don't have a company that is building all of these rockets and you're not a part of this. Should you still have a say in what goes into the type of life that we create in potentially a new colony? And so I certainly have concerns that if we can't figure out these issues on Earth, we're going to bring these same issues 140 million miles away and have those same issues on another planet. And so I agree with Terry here that we have to do this in parallel, that as we are beginning to try and figure out how do we expand, we also need to address what are the best ways to do it, how are we going to benefit everybody that gets there, and will we be able to make something better than what we have here? Hopefully it won't be like a New Year's resolution where it starts out pretty good for the first few months and then we kind of lose sight of what we're doing and why we're here.
We devolve immediately into cannibalism on Mars. There are interesting terrestrial analogs to this particular problem, and Antarctica is a great place to look. So when the Antarctic Treaty was signed in the 1950s, the idea was we set sort of a basic ground rules, and there were a couple other treaties that went along with this, but the idea was scientific exploration of Antarctica only. We're not militarizing Antarctica. If you want to go there, you have to develop infrastructure for scientific exploration. And if you do that, when we renegotiate the treaty in the 2040s, you will have a seat at the table, right? You did the investment, right? You got us there. We did some great exploration. We did not exploit that continent. We didn't drill for oil. We didn't start mining minerals. Now let's talk again. And I have a feeling that would probably be a useful model when we start talking about space exploration. I don't know if the time frames of the Antarctic Treaty would be quite so good. I would like to see like maybe every 20 years or maybe even 10 years. Let's talk about this. Like, who gets to be at the table? Well, who helped advance things? And let's renegotiate where things have gone wrong, because I think things will go wrong quickly. And I think things will go right quickly. I think it's going to be a little bit of both. I mean, we're human beings. That's just what we do. Anybody who wants to go live on Mars, hopefully we're not sending psychopaths there. But, I mean, so the first line in the Scarlet Letter, Hawthorne's book, was when the colonists came to North America, the first things they built were a church and a prison. And I have a feeling we're going to see the same thing on other celestial objects.
All right, with that very uplifting comment, I'd like to give all of our panelists a chance for some final parting thoughts, and we've got about a minute or so left. So we'll go down the line, and then we'll thank everybody for coming.
I guess I'll start since I'm on the end. I think I want to come all the way back to say that we are already using space to help us understand what's going on the planet, and hopefully we'll start using it to do better things and do better management of the planet. We humans do manage this planet, this spaceship. We do it not very well right now. We have the potential and the technology to do it a lot better. And so that's my hope for space in the near term. And then the other thing that I would add is a thread that we all sort of touched on but didn't say explicitly, is that this is a time when we need liberal arts thinking and studying more than ever, not less than ever. We need philosophers, we need artists, we need ethicists, we need people thinking deeply about our place in the universe and on this planet, and informing our policies and how we go about things, because we don't want engineers making those sorts of decisions. We just don't, and they are right now. And so I think, you know, I love the E.O. Wilson quote. We have Paleolithic emotions, medieval institutions, and godlike technology, and we've got to get our institutions and our emotions and how we approach the planet at least closer to par with where we are with our technological understanding, so that we can explore space and use it to our benefit and the benefit of every species living on the planet. So I will leave it with that.
Yeah, I absolutely agree with Ted. I think we should be very thoughtful about the choices that we make in the next few years. And I think we would also do well to remember that, you know, everything on Earth is limited. Our resources are limited, and space might seem infinite here, but we can't just exhaust everything that we have on Earth and plan for failure and leave when things don't work out. So I think we would do well to remember that this is the most hospitable place in the entire universe for us, and we need to make sure that we keep it that way, even as we set our eyes to kind of exploring more of the solar system.
I agree with what both of you have said, and I think there are lots of exciting places on Earth to explore, including the places that are our own homes and our own landscapes, and we need to bring the same kind of philosophy and thoughts and deep, broad thinking that's been referenced here today to our problems here at home.
I couldn't have said it better than what the three of them said. I will end on a political note. We are always one day away from the Dark Ages, and it is vitally important that we protect something very special that we've created. The scientific apparatus of the United States is an extraordinary human achievement that can be easily destroyed, but is not very easily recreated. And we must vote and talk amongst ourselves and do whatever it takes to keep this institution going, because it can very easily be lost, and it can certainly be destroyed.
Thank you all for coming, and please join me in thanking our panelists.